right, thanks for joining me. We're going to talk about linear error moves today, not error moves. Some people think we're saying error. I understand it's in loud environments, sometimes that happens. We're going to talk about the linear error moves today, and these are the moves that you would use to get to a position on your weld table. In this situation, we're doing welds. So we've got a part here, or a weldment, to kind of demonstrate us coming to this this weld to execute a weld on it. But before we do that, we have to get the robot in a position that's close enough. So let's say we started the robot here, and the robot, to get to, let's say, the weld in this position, it would crash into the top of the part. So we've got to get the robot over here first in order then to go in and start a weld. So to do that, first we're going to start a new program. So we hit New at the top center, and Program. It's going to ask us to save the changes or discard. We're going to discard in this case, discard the changes. And now we're going to add a move out of our THG Automation welding nodes on the left of the screen. So let's grab the robot and our free drive button, and see my thumb here at the top right of the screen. We press the button down, and you see that little box that shows up right here in the side of the screen. So we're going to move the robot over to this position, which now it can reach that weld. So on our screen, you'll see kind of in the top middle, I'm going to open up a down box. A down box shows two methods of moving the robot. One's a linear move, and then one is a joint move. So we're going to stick with this linear move for now, and we're going to go ahead and update the waypoint. So we should see a move screen, and we're just going to press OK. So now we've got a linear move. So if we move the robot back over here, and then we just press play, I'm going to shut off this program loop. We can discuss that into another video. So we're going to press play, and the robot moves over and stops. And that's the end of the program. So let's say we want to change this to a faster move. Let's say we're going to move from over here, right? And we want to move over here, right? So we could do a linear move like we had done in that first execution or that first example. But linear moves, what they do is they make the robot move at the tool center point, or usually where the wire stick out is on the welding torch, and it moves in a linear motion. So for an example, if you see across your screen, I'm going to move the robot in a linear motion back and forth, right? The robot is actually, or the controller is calculating or solving the motion while making a linear path in a direction from where it's at to where it's going to go. In this case, let's say we want to make this move as fast as it can from one place to another, not taking into account where the torch is. Now to do that, we're going to also create maybe some wild moves on the end of the torch, because the robot controller doesn't care necessarily about making a linear path. It just wants to move that thing over here. So we're going to put it in kind of a weird position here, and we're going to update this linear move we've got. I'm going to update the waypoint, and I'm going to press OK. So now our new position is over here. So actually it's off the screen there a little bit. Let's put it back, and then let's update it again. Now let's move the robot, let's say over here, right? Now that's where we want to start before we go in to do our weld. So we're going to create another move, and in this case, in the center of your screen, we're going to open up that down box again, and we're going to select joint. Now, if you notice, our coordinates, or our position information, the movement is actually going to be in a degrees per second acceleration and travel speed, versus in the linear move, we're traveling at an acceleration and travel speed. The difference is, in a joint move, we're going to move the joints of the robot, and joints being the joints here and here and here, all the way back to the base of the robot. So the controller is saying, well, I don't really care about the linear path of the robot. I'm just caring about where the joint should be when I get there. So let's move this, let's make this position here. Let's make this a position for a joint move. All right, and then let's hit start and see what happens. Now, if you notice something, when the robot moved back, maybe you saw it, it got real close to this clamp. So let's hit that again. Let's see what happens. So what we saw is, because we were going to go back here, the first move in our two moves on the screen, I just highlighted it, that move is a linear move. So the robot says, well, I'm here, and I need to go linearly back, and then I'm going to do a joint move over here. So it goes in a linear motion, a straight line, to this position back here, and now it's just going to say it's going to move all the joints so that it achieves this position here. So those are the two differences between a linear move and a joint move. Another example would be, let's say you came in here and you did your weld all the way across and you wanted to come out. Well, in that case, I would suggest not using a joint move, because a joint move doesn't really care about where the torch is at, or the tool center point, to be more exact. All it cares about is moving the joints. So in some cases, let's say if you moved up here, and you see how I've rotated this, let's say if I wanted to end it up right here, the robot may hit this plate, because again, it doesn't care where this tool center point is in relation to these two locations. It just cares about moving the robot to achieve the joint positions in which we told it. So if you're in tight spaces, really close to a part, really close to a clamp or something, you may want to do a linear move to get out. Now, if you're doing a big move with big rotations of one or two joints, then you may want to use a joint move. And that is the two differences between the moves. Thank you very much, and I hope you come back for more videos.